Yes, they are congruent. How do we know? Check it out. This is a reflection over y equals 2. So it's been reflected over y equals 2. Do we see that? It went up. And then it's been translated. That point went there. That point went there. That point went there. I don't want us to write the rule, but I want us to be able to understand the transformation. So it was reflected first over y equals 2, and then it was translated left and up. Okay, so we proved it with transformations. We can see that angle R is congruent to angle what? Where would it be corresponding? C. They're congruent because they're corresponding. So then side length OR, where does it correspond? Where would it be congruent? CP or PC, yeah. So it makes them congruent because they are corresponding on congruent figures. Questions? How do we feel? Great, let's flip the page. Let's do our quick notes. We'll do a couple problems on the check, and then we've got some homework. Here we go. Let's just officially define everything we were looking at. So the definition of congruence. Two figures are congruent if you can get from one figure to the other with rigid transformations. And we'll define that. Two figures. Hi. Are congruent. We're on page 11 right now. If you can get from one figure to the other with rigid transformations. And we're going to define this. Can you guess which ones are rigid transformations? Rigid. Yeah, perfect. Anything other than dilation, but I'm going to write it out for us. That would be reflections, rotations, and translations. Those are rigid transformations, and technically they are called isometries. We call these isometries. Okay? We also have to look for corresponding parts to match up. So I'm going to write a congruent statement. A congruent statement. Triangle ABC. Is congruent to triangle DEF. All right? Our corresponding parts have to match up. So angle A would be congruent to D, good. And angle B would be congruent to E, good. And angle C would be congruent to angle F, okay? Then if we list out the sides, that's the angles, the sides. Side AB would be congruent to DE, yep. And then we could list all these off. BC would be congruent to EF. And AC would be congruent to DF. Why is this important? Well, if we have congruent figures, their corresponding parts need to match up. Okay? I know I just wrote a lot. How are we feeling? So, yesterday's lesson, day before's lesson, we defined similar figures. Today we're defining congruent figures. Cool. I want you to do 1, 2, and 3 in the check for understanding. Ready, set, go. Yeah. I did the first one in one part A. If AC is congruent to NE because the figures are congruent, then you can say A is 4.9. You need to find B and C too. Then it's going to ask you about angle measures. How about part B? If you know angle A, it's congruent to what angle? N. So then you could say the measure of angle N is 72 degrees. And the other angle is S. If I know angle S, it's congruent to H. So then I could say the measure of angle H is also 37 degrees. Questions? Did you guys try 2 yet? Which of the triangles below is congruent to ABC? What'd you guys get? IGH? Yep. What'd you say? And then 3, it's multiple choice. Which one? Good morning. Which one is not an isometry or rigid transformation? C. Good. We'll write that in really quick. So we should have gotten C. We should have said triangle ABC is congruent to triangle G. Hi.
Do you need this?
I sure do. Put it here. I got a pile. Here we go.